Welcome. We're going to take a look here at our Semester 2 cumulative review for Consumer Math. This semester we did cover chapters 6 through 12. Even though we didn't take tests over all the chapters, they are all included at least a little bit within the review and the test. Just to give you a little bit of background or a little bit of idea of what to expect here, the review homework assignment is 30 questions long, so it's really just the very basics of each chapter. Not a whole lot of really in-depth work, more of just an overview. And the semester 2 test is 15 questions long. Every question from the test comes off of the review. So spend your time on that review, ask any questions that you have, make sure you understand the concepts. If you feel confident in your review, you should be good to go for the test. The review we're going to do together in this video is a little bit more of a conceptual review. We'll talk a lot about what things mean, and in your homework you'll have a similar question about the concept, and then you'll most likely have an application problem for a lot of these as well. If you're not sure how to kind of extend from the concept to the application, let me know and I'd be happy to go over that with you. Just a reminder, all work is due May 26th, including your assignment or your test and your review. Your test is 200 points and your review is 20. All right, so let's go ahead and jump in here. We started chapter 6 with talking about the mean, median, the mode. I'm sure there are things that you had learned before, so we're just going to quickly review what each means, and you'll have a time to practice it in your homework. A mean is what we typically refer to as our average, although that word average can mean a lot of things, so we talked about kind of the issues you can run into using the word average. But to find the mean, you add up all of the values you have and then divide by the number of values. So the mean is the sum of all values divided by the number of values in your data set. Your median is going to be the number that is in the middle of your data set when your numbers are listed in either descending or ascending order. So median is just your middle value. And lastly, your mode is the value that is most common in your data set. And as a reminder, you can have no mode, one mode, or multiple modes. If you have one number that occurs 3 different times, or you have 2 numbers that occur 3 times, then you'd have 2 different modes. Now, also with talking about our values in chapter 6, we looked at normal distribution. And what does that mean? And you spent some time doing things like finding z-scores. We're not going to get that in depth for our review or the test, but it is good to remember what it means to be normal. So a normal distribution is a symmetric bell-shaped curve with a single peak. And I'm going to attempt to draw an example here, but please bear with me as my drawings are awfully quite ugly. So it needs to be symmetric, so it comes up on the left. Oh, that's bad. Let me try again. Up the left, down the right. Bear with me. That's not the best curve. But and then that top peak in the very center is going to be our mean, and we kind of use like a cursive U to represent that mean. And as we get further and further away from the mean, we're changing by standard deviations. And again, you're not going to have to find those values. Just be a little bit familiar with what they are and what they look like. All right, then we moved on to chapter 7, where we looked at probability of things happening. And you spent a lot of time on projects in this chapter, so we don't have a lot of questions to review it. Just being familiar with knowing how to find the probability of something, things like outcomes and events, and the difference between theoretical and relative probability, and you'll have a question on that in your homework as well. So this question says, use theoretical method to determine the probability of the following outcome and event. State any assumptions made. So we're going to be tossing 2 coins and we want to know the probability of getting either 1 head or 2 heads. So the first thing that I like to do is I like to list all of my outcomes. What could happen? How could I have this happen? I could get heads the first times and heads the second. I could get heads the first and tails the second. Tails first, heads second, or tails both times. So those are all possible outcomes. Now I'm looking for the probability of getting 1 head or 2 heads. The first one is 2 heads, so that counts as an event. The second has 1 head, and the third has 1 head. So when I find the probability, I take the total number of events, the times that happens, and that happens 3 times, divided by my total number of outcomes. There are 4 possible outcomes. So there's a 3/4 probability that I will get at least 1 or maybe 2 heads if I flip 2 coins. be comfortable with that. If you need help, please let me know. Then we moved on to the next chapter looking at the difference between linear and exponential growth. And you spend some time graphing linear functions. You'll have a little bit of that in your review assignment. And just being able to identify the differences. So if we want to describe the differences in vocabulary terms, then we say that linear growth grows by the same absolute amount. That's not how we spell amount. And absolute amount means it grows by the same number or decreases. We can see linear decay as well, going down by the same amount. But it'd be something like each year my car depreciates $500, or each year my model plane grows in value $300. That's linear. Remember, our root word in linear is line. So anytime you've got a line, you're talking about linear growth. Exponential, on the other hand, grows by the same relative amount. And that means percent. So my car might depreciate 30% each year. That would be an exponential decay. Or my model airplane might grow 10% each year. And remember, an exponential curve usually starts slow and then grows very quickly. Something like that is an example of an exponential curve. So just be familiar with knowing the differences, identifying them, and maybe doing a problem or two coming up with a value using linear or exponential. All right, then we went on chapter 10 and we did a nice little review of geometry. And in the review for the semester, it's all very straightforward questions. There's not a whole lot of in-depth new material for the review. It's going to be mostly things you've learned in the past. So this is just a very quick review on finding perimeter and area. You have a few with, I talk about circles a little bit too, and I think there's one with a three-dimensional shape, but it should be primarily reviewed from other years, just to kind of refresh for you. So here we've got a parallelogram. We want to find the perimeter and the area, and we know these certain things about it listed in my picture. So remember about a parallelogram that opposite sides are congruent, so I know that the bottom is also 17 feet, and the left side has to be 5 feet. So let's start by finding the perimeter, and our perimeter is just the distance all the way around, so a variety of ways you could write this. I'm going to take 2 times 5, since I have 2 siblings that are 5, add that to 2 times 17, since I have 2 siblings that are 17, and I have a perimeter of 44 feet. And for area of a parallelogram, we use the formula base times height, just like with a rectangle. And what's important is that your base and your height are perpendicular distances. So whichever you choose to be your base, your height has to be perpendicular to that, or create a 90-degree angle. So notice here I could not choose the 5 as my base because I don't know the height between those two bases. I don't know the perpendicular distance there. What I do know is that my height 2 between my two bases of 17 is given. So I'm going to use 17 and 2. And 17 times 2 is 34. And area is always your unit squared, so 34 square feet. And in this review, I didn't include any chapter 12 material since we just finished that chapter 12 chapter, and in our last DI, we did a chapter 12 review. So there is no chapter 12 review included in this video or in these notes. There is a little bit of chapter 12 in your review assignment and in your test, but it should be very straightforward. All of it, anything that was covered in the video from the last DI, week 37 DI, will also be included in the review assignment. If you do need a little extra chapter 12 review and that DI isn't cutting it for you, let me know. I'd be happy to go over that. So the last thing that we did talk about before we got to chapter 12, looking at voting, was talking about symmetry. And you didn't have a chapter 11 test where we talked about things like perspective. We talked a little bit about music. We talked a little bit about Fibonacci sequence. But you did do some writing assignments about it, so hopefully you're fairly familiar with it. Again, the questions are very basic. Basic understanding rather than a lot of application here. So here we're just asked to describe the differences between reflection, rotation, and translation symmetry. And you did a writing assignment about these where I wanted you to find them around your house. So this should be something that hopefully you remember from finding them in your daily life. In case you don't remember, let's just run through these quick. Reflection symmetry means that the object remains unchanged when reflected across a straight line. I like to think of reflection symmetry as fold symmetry. If you can fold that object anywhere and the left side lines up with the right side, that's reflection symmetry. Rotation symmetry happens when the object remains unchanged when rotated through an angle. And I like to think of rotation symmetry as turn symmetry. If you can put your finger in the middle and turn it, and without going all the way around, it ends up on itself again, that's rotation symmetry. We can identify how many rotation symmetries we have based on how many times we could rotate it before we get back to itself. And we can find the number of degrees that it rotates before it lines up on itself, taking 360 and dividing it by those number of rotational turns. And our last one is translation symmetry. And translation symmetry happens when an object remains unchanged when shifted in a certain direction. This is like your tiling. You can shift your tiles left and right, and they're going to line up right back on themselves. So pretty quick review here, but like I said, the assignment's only 30 questions long, and it just covers those basic concepts from chapter 6 through 12. If you have any questions or you want to go into anything more in depth, let me know. Otherwise, good luck.